we will begin topic 2 with accuracy versus precision. Accuracy is defined as the closeness of a value to an accepted value. So as you look at a given and you compare your results, it's your value compared to an accepted correct answer. So how close are you to that value? For precision, we're going to look at the closeness of all of your data. How close is all of that data to each other? So the closeness of measurements of the same quantity. How reproducible are your results? We will often find out how accurate we are using percent error. So you're going to use your experimental error. This is what you actually get in the lab. Subtract that from the accepted value, and then we are going to divide that answer by an accepted value, and we multiply it by 100 because it is a percent. Now you may find that you are getting negative percent errors. And that is just because your experimental value is going to be less than your accepted value. So a negative percent will mean that you are under the accepted. But it is perfectly okay to get a negative percent error. Second thing we're going to look at tonight are significant digits. Everyone's favorite. Maybe you remember these from back in biology, maybe even back to IPS. So why do we use significant digits? Well, that's because the different instruments that we have will have different accuracies. For example, you use a 10 milliliter grad, we can get it accurate to 2 decimal places. However, using your 50 milliliter grad, you can only get it accurate to 1 decimal place. So if you're using both of them, you have to go by your least accurate instrument. So rules for determining significant digits. Basically, all non-zero numbers are going to be significant. So any number 1 through 9 that is in a number will be significant. Zeros at the beginning are never significant. So what we're talking about here is 0.03. This zero's at the beginning. Or if you had 0.03. These zeros are at the beginning. That means they are not significant values. Do you need to write them? Of course. They're going to hold 3 in a place value, but the zeros themselves are not considered significant. Sandwich zeros are always significant. These are going to be like your 101, where it's sandwiched between the ones, or a 10001. These are still sandwiched between the ones. Even if I put a decimal place in here, the zeros are still sandwiched by 2 non-zero numbers. And then zeros at the end of the number. This is where the dot means a lot comes into play, because they will be significant, or always significant, if a decimal point. So the dot means a lot. The dot means a lot. If you had me for IPS, you're probably sick of hearing me say that. If there is no decimal point anywhere in the number, then zeros at the end are not significant. For example, if we have 10.0, all of these zeros are significant. However, if we just write 10, that 0 is not significant. So it doesn't matter where the decimal point is, it just needs to be somewhere in the number. Even if we had 0.100, those zeros will be significant because there is a dot in your number. Now, we don't just look at a number and determine how many sig digs. Often we are doing some kind of math with the numbers that we had to measure. So it's not just, oh, how many sig digs are in this number. We're usually doing something with those numbers. So if we are adding or subtracting, we're going to go by the least precise place value. So if you're adding something with 2 decimal places, adding it to something with 1 decimal place, your answer is going to just have 1 decimal place. Where with multiplication and division, this is where the significant digits really come into play. How many total sig digs are in our numbers? Which one has the least number of sig digs? And we're going to round our answer to show the lowest number. So least precise place value, you can also think of as lowest number of decimal places. Where this is lowest number of sig digs for multiplication and division. Always the lowest, but it just depends on if we have to actually determine those significant digits. Last thing we're going to look at tonight is scientific notation. So scientific notation just takes really big numbers or really small numbers and makes them easier to work with. So they take on the form of m times 10 to the nth. So we're going to take some number m, that's a number between 1 and 10. It can't equal 10, so think of one value before the decimal point. So you can only write one number, then a decimal point. Then you're going to take that number to some power of 10. Now, if your number is greater than 1, this n, which it seems very hard to read, there's an n there and there's an n here. Those n's are going to be positive. So if my number that I originally started with is greater than 1, my n is going to be a positive number. If the original number I started with, so again, we're looking at original numbers, is less than 1, then my n is going to be negative. Now it will work in reverse, the same idea. If you have a positive n, you're going to make a number that is greater than 1. If you have a negative n, you're going to make a number that is less than 1. Don't think of it as you're going to the negative side of like a number line. That way we're not going to think of it as less than 1. We're going to think of more of the absolute value. So what we mean by a number being less than 1. So these start with a decimal. So if you have a very small number like 0.00000001, this is a number less than 1. It's a number that starts with a decimal point. Positive numbers or positive exponents, numbers that are greater than 1, are going to be like 1,000, where they're greater than that. They don't start with a decimal point. Now what you're going to want to know how to do is how to do scientific notation with your calculator. The easiest one to do is doing this Texas Instrument calculator. So if you're unsure or you don't have the buttons that I'm showing you now, then please bring your calculator to me and we will show you how to do it with your calculator. So if you have a TI calculator here, you're going to use the EE or the EXP button. That is located right over here. Should probably do that in a different color. Just a second. So here is our EE. So you're going to do the second to this button and you have your EE. So that's what you are going to use. Some of you may actually have a button that says EXP on it. What we want to get away from is using this X to the Y button or this X squared button or even using the caret. We want to get away from that. Just because when we use this EE button, it makes our math a little bit easier. We don't have to worry about order of operations as much. We don't have to worry about parentheses, because when we need to or we start using those buttons, we often are off by a couple of powers of 10. So why don't you try it? Type in 6.02 times 10 to the 23rd. So to put this in your calculator, you're going to type in 6.02, then you're going to do that second EE23. And you'll notice that your calculator is going to give you 6.02 E23, or that's what it'll look like when you type it in. So this E here that you type in is EE. You don't actually type in 2 E's, so that there's 2 E's here. If you use that EE button, it just leaves you 1 E. That's what it'll look like typing in. Now when you give me numbers back as answers, you're not going to keep it E. This E is equal to times 10. So that you just have to remember that's how we are using it. Again, if you have any questions on how to use your calculator when you do this, please ask.